Here we go. 4.1. A town's population has been growing linearly. Now, what does that mean? Let's stop right on that word for a second, because that's what this whole chapter is about. 4.1 and 4.2, all of chapter 4, is about linear functions. Linear functions. Now, what do you think a linear function? What word is in there? Line. That means if you graphed it, it's going to be a straight line. That means, what are you talking about, population? That means this town, its population is growing like a straight line. Now, there's other ways to grow, You could grow in a curved fashion. That's called well, it depends what the curve is, but that could be a lot of different curves. So there's all kinds of ways things can change over time. Linear is really the most simple way. Straight line. That's the most simple way something can change, grow, or if it decreases, go down over time. But then there's more fancy ways we'll do in other chapters, like, going like a curve and stuff. That's more advanced math when things change in a curved fashion. There's all kinds of curves. There's x squared, there's exponential curvature, logarithmic. We're going to do all that in a few weeks. But for now, we're just going to start with linear. So this whole chapter is about linear functions, things that are changing in a straight line. Okay, let's get back to the question here. So the town's population has been growing linearly in a straight line. In 2003, the population was 58,000 people in that town. The population has been growing by 700 people each year. Write an equation for the population P, X years after 2003. Okay. Well, one thing I learned a while ago when I was taking my zillions of math classes they made me take when I was in college is that I thought a lot better with real life numbers than I do with X's. So I learned that sometimes when I'd read like a kind of confusing word problem like this one, and they're asking me for some kind of magic formula, I learned that if I would just think about numbers instead of X, if I would just think about real life numbers, I'd do a lot better. And I think we're all that way. Let me show you what I mean. What if I asked you, what's going to be the population in the year, 2007? Let me just stop there for a second. I bet every one of you can do that. Let me give you a second. Calculate for me. Remember how it's working. In 2003, the population was 58,000 people, and it's going up 700 each year. So I'd like you to write out what you're doing. Rather than calculating, I don't really even care what the answer is. I care how you get the answer. So write down what you would do, like what would you add, subtract, multiply, or divide to get that answer. And once you do that, stop. 58,000 people in 2003. 2007, what's it going up 700 a year? What's it going to be in 2007? So what would you do? Again, I don't care what the answer is. I care what would you actually do? You would do what's that? 700 times 4 plus 58,000. Beautiful. It's exactly what you would do, right? I think every one of you knows that. Right? We think so much better with numbers. Yeah, it's exactly right. I'll make this at times with parentheses. But yeah, 700 times 4, because it's 700 per year, and that's 4 years later, plus 58,000. Okay? Excellent. Now, why the 4? Why did we put in the 4?
How many years from 2000?
Yes, this is 4 years from or after 2003, Right, that's how we knew it was 4, because it's 4 years later and it's going up 700 a year. So, right. So that would be the P, that would be the population, wouldn't it?
All
right.
So put down population 2003.
Hold on. Now, what are they asking us to do? They're saying write an equation, which is what we just did basically. But they're saying X years after 2003. So this right here is for how many years after 2003? That's 4 years after 2003. So how are we going to do X years after 2003?
700 times X plus 50.
That's our answer. There it is. See how you knew just what to do with the 4? And then just do with the x what you did with the 4. We think so much better with numbers, don't we? When I first saw that, I was shocked how much better I think with numbers than I do with like an x. X is like x. What's that? But with 4, I'm like, oh yeah, I know what to do with the 4. Well, the x is the same thing. So that's our answer to the first one. 700x plus 58,000. X is just the number of years after 2003. And so you multiply it by 700, huh? And add the 58,000. Good. And then it says, use this formula to find the population in the year 2009. How do we find the population in the year 2009?
So instead of the plug in of 4, you just plug in what it was 7.
Yeah. How far is 2009 from 2003? 6. Perfect. So we'll just take the 700 times 6, because that's 6 years of growth, isn't it? Add the 58,000, and you get some answer, whatever it is. 62.2? Is that what it is?
Nice.
62,200. Good there? You like how that's real?
Yeah.
All right. Let's try number 2. Is the equation y equals 73x minus 22 increasing or decreasing? Well, let's actually, to answer that, let's go back and think about this equation we just came up with on question number 1. If we were to, actually, you know what I would be better to do? Let's go back here. There's a lot of questions in this section. All right, so let's think about, do you remember, maybe not, let's see, 3, all right, let's make it 2/3 x, well, forgot the x, 2/3 x plus 4. Do you remember anything about how you graph? Let's graph one of these. And we'll let that lead us to the other things. Yeah, how do you take an equation? That's a linear equation. Have you seen the y equals mx plus b thing before?
Yeah, that's rise over run.
Yeah, exactly. It's all that stuff. Exactly. Yeah, mx plus b. The m is the slope, isn't it? It's the, like Dennis was saying, it's the rise over the run. Does anybody know what's the 4 then? What's the b, the 4? Good. You guys know a lot of this stuff. Yeah, it's the y-intercept. Meaning, this is the x-axis and this is the y-axis. It's where the graph hits the y-axis, huh? So that would be up 1, 2, 3, right there. I'm just going 1, 2, 3, 4. So right there, that would be the y-intercept. So when we graph an equation, y equals mx plus b, you start with the y-intercept. You start with this guy first. Start with him. If that was a -4, then I would go down 4 and I'd put a dot at -4, huh? Right, you with me? It's always on the y-axis. It's up for positive, down for negative, right in the middle line, the y-axis, right? All right, so anyway, so that's the first dot. Now, we only need 2 dots to make the line, don't we? If we can just get 2 dots, connect the dots, we've got our line. So how do we find the second? So the first dot is just whatever number is off to the right. That's your first dot, right in the middle line, positive 4, up 4. Okay, and then how do we find the second dot?
Right.
Go up 2, over 3. Yeah, this is the slope. Rise over run. And we do that from the first dot, not from the origin, huh? But from the first dot, go up 1, 2, over 1, 2, 3. Right there. And then we connect the dots. And that's our line. It goes forever in both directions. So when up 2, we rise 2, and go over 3. That's the run, like people run sideways on the ground. And the rise is up, and the run is sideways. Up 2, over 3, connect the 2 dots. Okay, so I think you know that already. Let me change it now a little bit. Back to number 2. Again, we're still working on number 2. What if it was like -3x plus 2 or whatever? Yeah. Can we graph that one? So where would... Can you put your first point and then your second? Okay, so up 2. 1, 2. We good there? And then, so that's the first dot. How do we find the second dot?
Turn that into a fraction.
Make it a fraction, right? Because that's the same, right? Anything divided by 1, we haven't changed it.
So it's down 3.
Yeah, rise or yeah. So how do you rise -3? Yeah, you go down 3, don't you? So from the first dot, not from the origin anymore, right? But from the first dot, go down 1, 2, 3, and over 1. Down 3, over 1. So there, right here, is the second dot. And then you connect the dots. And we've got our line. Good? Okay, so that's general graphing. That's y equals mx plus b. Now, does that line increase or decrease? Is that line going up or down?
It decreases.
Yeah, and you know, like
So
if you...
left to right, just like a book.
That's right, exactly. At least English books, Chinese books go, and Hebrew books go the other way, I think. But yeah, we know what we mean. So as you go to the right, you're going down, huh? So in other words, how could we look at this equation and know right away that the line's going to be going down? That negative means it's going to be decreasing. It's a negative slope. It's going to go down and over, huh? Whereas the last one, it was a positive. There's nothing there, which means positive. That's an increasing line. It's going to go up to the right. Okay, with all that in mind, 2 will be an easy question now. There's a lot of questions there. All right, so number 2. Here's the function. Is that going to be an increasing or decreasing function? Yeah, it's increasing because of that 73 being a positive 73. We good there? That's all we need to look at. The slope, the number in front of x, the m, is positive. It's increasing. How about number 3 now? Number 3, they want us to find the slope of the line that goes through those 2 points. Do you remember the slope formula?
y2 minus y1 over x2.
Yeah, y2 minus y1 over x2 minus... By the way, that's the same thing as rise over run. See how it's y values on the top and y's up and down, rise? See, that's really just rise over run. All right, so yeah, that's what we use. And remember how the points go. This is x and y. This is the first x and y point. And this is the second x and y point. So first x and y point, second x and y point. So we'll get the slope between those. Okay, so y2 minus y1 over x2 minus x1. We good there? And so that's what, minus 27, right? You know, this is if you lose $14 and then you lose $13, you lost $27, a lot of dollars. And then the bottom, if you lose $10 and lose $4, you lost $14. Good to there. And then we got 2 negatives. They cancel to become positive, and that's our answer. We can't really reduce that fraction. Nothing goes into 27 and 14. I know because that's 3 times 9, and 9 is just 3 times 3. So only 3s go into the top, and only 2 and 7 go into the bottom. That's just it. That's the slope, 27 over 14. Analyzing everything. Yeah, let me show you that. Let me do it with easier numbers. How about if I had -2 over -3? I'll show that it's the same thing as positive. Here we go. Let's start right here.
It'll start different.
This is rise over run. This is rise over run. Let's start with the positive one here. So from here you'd go up 2 over 3, right? So this is the line you would get, right? For the other one, you would do what? Rise -2 and left 3. Boom. Look at that. Different point, but the 2 dots would make exactly the same line. Does that make sense? See how the 2 negatives still make, when you go down 2 and back 3, they still together make a piece of line that's increasing, going up to the right. It's a visual proof that 2 negatives do make a positive, don't they? Good question. All right, back to number 4.
Now, my question with this on number 3 is, didn't we learn this in chapter 1?
Yeah, it's kind of, there's some reviewing going on, which is good. It's kind of good to kind of circle back and strengthen what we knew before.
Yeah, but we didn't know what we were doing.
Now we know more. All right, so number 4, we've got a graph here. And we're looking at that and they're saying, okay, find the slope of that line. So now we're going to do slope from a graph by looking at a picture. The easiest way, I think, to do this is to grab some points that are right on hash marks, you know? So like the origin for sure, right here. And then what's another dot that's clearly right on two lines crossing at hash marks?
5 feet.
Yeah, that's what I'm seeing too. That one right there that's over 5. Yeah, up 3. Yeah.
No, you got this one.
So let's calculate the slope. Remember what slope is? Rise over run.
3 over 5.
So let's start here and go 1. Now, and remember, you're counting jumps, not lines, huh? I didn't know that when I was taking high school biology. I still remember my kind high school biology teacher. I was trying to do something on my little notebook with graph paper, and she came over very kindly. I was counting lines. Like I would go 1 line, 2 lines, 3 lines, 4 lines, like that. And she came over and went, no, Brett, we're not counting lines. We're counting jumps. So, yeah, that was a good lesson for me. So, right, we're counting 1, 2, 3. It's up 3, not 4. We're not counting lines. We're counting jumps, huh? So, up 3 jumps and over 1, 2, 3, 4, 5 jumps. So, up 3 jumps, over 5 jumps. Rise 3, run 5. There we go.
Wait a minute. Oh, it depends on when you start counting your lines.
What do you mean?
Because counting your lines is the same.
Oh, well, yeah, if you count the one you're actually on,
Who does that?
well, that's what I did. I was a little
No,
goofy.
like, wait a minute, I count.
That would be dumb. Well, yeah, I was a little dumb.
But that makes sense, though, for the jump.
All right, so we got our slope. All right, so now, is that all they wanted? Oh, yeah, okay, I thought there was more. Okay, good, we're done with that one. So they just want the slope. I thought there was more. All right, so on to number 5. Okay, a city's population in the year 1977 was 1,591,050. In 1953, it was that lower number. Okay, compute the slope of the population growth or decline and choose the most accurate statement. Okay, so how much do they want us? Notice all the answers. They want us to figure them out in terms of per year. Can you do that? Yeah, so basically to figure out the people per year, so what we have to do then is just subtract the 1,591,050 minus the 1,580,250. Subtract those. Somebody got that number? Is it 10,800? Okay, 10,800. All right, and then subtract the years. That was 1977 when it had the higher population. 1953 when it had the lower population. That's what, 24 years. So the population grew from 1953 to 1977. Population grew from the lower number to the higher number. So it went up 10,800 in 24 years. So we just, what do we do with those numbers? Divide them, right? Because it's that many people divided by 24 years. Somebody got a number there? 450. 450 people per year. Is it decreasing or increasing? It's increasing. It went up from 1953 to 1977. Increased by 450 people per year. Is that good? Very much real. Okay. So number 6, on a bicycle, Maggie rides for 6 hours and is 14 miles from her house. After riding for 12 hours, she's 26 miles away. What's Maggie's rate in miles per hour? How fast is Maggie going in miles per hour? Can you figure that one out? Like, in other words, and no, we don't have anything that hard in this section. So after 6 hours, she was 14 miles away. And then after 12 hours, she was 26 miles. So from the 6-hour mark to the 12-hour mark is how many hours? That's 6 more hours of riding, huh? Right? They're telling us how far she was at the 6-hour mark and then how far she was at the 12-hour mark. So that's 6 hours later. She'd gone, what, 26 minus 14? She'd gone 12 miles in. So what do? I divide by the 6 hours, don't I? So she's going 2 miles per hour. A little slow. She's not moving too fast there. Is that making sense? Right? At the 6-hour mark, she was 14 miles from home. At the 12-hour mark, she was 26 miles. So she covered, subtract that, 12 miles in 6 hours. That means 2 miles per hour on average. That's her speed. 2 miles per hour. A phone company charges for service according to the formula there, where N is the number of minutes talked and C of N is the monthly charge in dollars. Okay, so the rate of change is, the initial value is. Okay, so we're going to start getting more and more into these kinds of linear formulas. This is basically a y equals mx plus b kind of formula. So we've been calling m the slope, which it is, and b is the y-intercept, which it is. But another way that they're going to refer to those two pieces, those two components, is they'll say, yeah, m is the rate, and b is the initial or fixed amount. Why? Well, slope is a rate. Like back here. Look back here for a minute. Right? This was a rate, certainly 2 miles an hour. That's her rate of speed. See how it's a slope? See how we did it with a slope calculation there? Fraction, one thing over the other. A slope is a rate. A rate is a slope. I don't know if you've ever stayed up late at night and thought about that. Said, you know what? All speeds in life, when I talk about how many problems per hour I can solve or miles per hour I drive in my car or ride my bike, that's always a slope. Probably not. That's just what strange math teachers do. But it's true, right? Slopes are rates, okay? So they're going to start calling this slope a rate. And then the number at the back, that's always the initial value. Remember when we graphed back here? And I said, right here, and I said, the number back here is what you start with. It's your first point on the graph, up 4. It's your initial value. It's the starting amount, isn't it? So that's what we're talking about. Okay, so therefore, when they give us this equation, which one of those numbers is the rate of change? Yeah, this is the rate. You know how you know? Because it's next to the letter. So the one that changes is next to the one that varies is next to the variable. The one that changes, the one that's a rate, is next to the variable. So that would be 0.02. And the initial value, that's the other one. That's the 14.
So rise over run. You said starting point.
So the y-intercept is the one not next to the letter. See how b is not next to x?
Okay. I got you.
So it's this one. So that's the starting point. That's the y-intercept. And the one next to the letter, that's the slope. The one next to the letter is the slope.
Oh, okay.
Yeah, like in y equals mx plus b. See how the m is next to the letter?
Yeah.
So he's the slope. So the one next to the variable is the slope, is the rate.
So let me erase that.
All right. And so now on number 8, they want us to find the equation. Now, I think we might have done this before, didn't we? But it's hard and it's complex. I definitely want to do it again. So let's go to that. And what do they want from us? They want the equation. Find the equation. All right.
So wouldn't it be the same thing we've done before?
We start that way. So step 1 is to find the slope. But then we have more after that.
Okay.
Yeah, so let's start with the slope. Can you get the slope first off? So the slope, what's the formula? It is, y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. So it's going to be y2, 12, minus y1. Negative, did you catch the double negative there? Right, there's the negative in the formula, and then the plug-in was negative also. x2 minus, and then x1 is negative, so two double negatives. You know that's add. And so what's that? 18 over 6, 3? So we got a slope of 3. Okay, so that's step 1. And then step 2. Now this is where I do something a little different than you're probably going to see in that little video. I don't care how you do it on the test. Anyways, fine. But I think this is my method's a little easier because it avoids fractions. It's when you put the blanks at the back. Have we talked about that before?
Oh, okay.
I think we have. Yeah, so we're back to this again. Where you put, so it's kind of like using the slope formula twice, but the second time it's an easier version where you just have plain y and x instead of y2, x2, 7, and blanks at the back. Remember that? And then you're going to grab, so what we did on step 1 was to get the slope. So you grab that slope from step 1 and plug it in on the left. So put the slope there. And then what are you going to put behind the y and behind the x? Yeah, you can just grab the first point or you can grab the second. It doesn't really matter. But careful, make sure you put the x behind the x and the y behind the y, not vice versa. And it's tempting to do it the other way because the very first one you grab, we tend to want to put that on the top, but that actually goes on the bottom because x's are on the bottom. That's an easy mistake I've seen many people make over the years. So make sure you put negative 2 on the bottom, minus 6 on the top. Put the slope over here, which is going to be, so we'll have 3 equals y minus 6 over x minus, and you know those double negatives are going to become positive, right? Is that good so far? So I plugged in the slope that we found in step 1. So and plugged in the numbers behind the x and the y. And now what do we do? What do we do when we have a fraction with an equal sign? Cross multiplication. Put this over 1. Diagonal, diagonal. Remember that? So go ahead and distribute. In the end, they want us to get y alone. So 3 times x plus 2 is 1 times y plus 6. So that is 3x. So that 3 distributes, right? 3x plus 6, and 1 distributes is y plus 6. And last step to get y alone?
Take the 6 over.
Subtract the 6. Boom. Y is alone. This cancels too, huh? It's just y equals 3x. And we're done. Yep. So back over here, it says, what number was it? 8. Yeah, it says, find the equation in terms of x. And what it means is we got 3x, meaning this thing has got to have in terms of x, got to have x in it. Yeah. So we got y, but see how they have y alone over here? Yeah, so getting y alone and a formula with x on the other side. There it is. All right. Now let's try, now let me tell you this. We're about to go through 3 or 4 or 5 problems. They're going to try to make them messier and messier with more and more words and more fancy stuff, but they're all really what we just did. Pretty much exactly the same thing we just did, meaning what? Where you have the 2 points, and you first find the slope, and then second use the slope formula again, and cross multiply and get y alone. They're the same thing. They're just going to try to give it to you in more and more tricky and subtle ways. Like here comes number 8, or 9 for starters. See what they're saying here. This has got to be the x. Because remember, see right here, whatever's in the parentheses of a function is always x. So that means this is x, and this is y. No, this is x1, y1. And this is x2, and this is y2. So in other words, they're giving us minus 3, minus 5, x1, y1, and 4 minus 4, x2, 2, y2. Like that. Do you see that that's what they're doing? How do I know that? Well, that's the language. Whatever's inside the parentheses of a function is x. And whatever it equals is y. So in other words, do the exact same thing you did last time. They're giving you 2 points. So go through the same 2 steps. Step 1, find the slope. Step 2, once you have the slope, plug into the easier slope formula with the blanks at the back. Cross multiply, get y alone. This function right here is y. They're just asking for y. It's the same thing they asked for last time. They're just calling it f of x now, but it's the same as y. It's exactly the same. Jump in as well. So step 1, the slope, y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. So y2 minus y1, negative 5 over x2, 4 minus x1, negative 3, negative 4 plus 5, over 4 plus 3, what's that, 1/7? So the slope is 1/7. And then we start the slope formula again a second time. But this time we write y minus blank over x minus blank.
And 1/7 in front.
Yeah, exactly. So we grab that 1/7 that we just found from step 1 and we put it in the slope slot. It is the slope. And then behind the y and behind the x, we put an x and a y. So grab the x right there and put that negative 3 back there and grab the y. Put that y back there. So we get 1/7 y plus 5 over x plus 3. Exactly like the last one. Cross multiply and solve for y. So we go diagonal, diagonal. So 1 times x plus 3 is 7 times y plus 5. Like that. And then distribute. X plus 3, distribute. 7y plus 35. Like that. What do we need to do to get y alone there? Yeah, y is saying I want to be alone. Yeah, so we subtract the 35. Very good. Is that good? Okay, so then we're going to get x minus, what is that, 32 is 7y. And how do we finish getting y alone? Divide by 7. So you can just do one big 7 like that, or you could do separate 7s. So in other words, y will equal x minus 32 all over 7, or you could make it, each one has their own separate 7. It's the same either way. This or that. Both are good. They mean the same thing. You know, when you divide the other side by 7, you can do one big bar or two separate bars. Same thing either way. Is that good? Yeah, you said, yeah, 1/7. Yeah, that's the same thing too. Yeah, why is it 1/7 x is the same as x over 7?
There's always a 1 in front of it.
Yeah, because there's really a 1 here. The x could really go right back to the top. Yeah, so for the x to be in front or alone is the same as to be in the top, isn't it?
Well, that's why I put 1x minus 32 instead, because it's the same thing.
Yeah, it's exactly the same. So to be in the front is to be in the top. They're one and the same. Because when you're alone, you're really over 1, you're really in the top. Good. All right. So you guys are getting used to this language.
So the trick with that one is, once you find the y-intercept and x...
Number 10 here. So a clothing business finds there's a linear relationship between the number of shirts it can sell and the price P it can charge per shirt. So in particular, historical data shows that 2,000 shirts can be sold at a price of $39, while 2,100 shirts can be sold at a price of $34. Give a linear equation in the form of P equals MN plus B that gives the price, P, they can charge for N shirts. Now that sounds fancy, but guess what it is?
MX plus B.
It's exactly what we just did in the last two problems. Let me show you. This is X1, Y1, X2, Y2. They're telling you, was it 20,000? 20,000, comma, 39. And 21,000, comma, 34.
Are they always like this in general, or are these just?
That's what this section is mainly about. Yeah, do you see that? It's just, yeah, their equation that they have here, P equals MN plus B, that's just Y equals MX plus B. But they just changed the letters a little bit. That's all. Let's just do it with X and Y, and when we're done, we'll give them back what they want. It won't be hard. So it's the same thing. Yet again, you up for doing it one more time? Let's do it one more time. Same two steps. Step 1, find the slope. Step 2, use the slope formula, cross multiply. So do the same thing. All right, so let's try this now. So I'm going to go back and do this problem back here. So this is number 10. So they're basically giving us 20,000, comma, $39, 21,000, comma, $34. Slope equals, this is x1, y1, x2, y2. 2 minus y1 over x2 minus x1. So 34 minus 39 over 21,000 minus 20,000. So minus 5 over 1,000. Oh yeah, did you guys reduce that?
Oops.
You don't have to, but it would make life a little easier for you.
Oh, too late now.
Yeah, did you guys just leave that the way it is?
I did. Only because it's right there.
Yeah, it'll work. It's okay. It would be simpler if you divided top and bottom by 5. It would make the number simpler for you. But here, I'll go on and do it that way anyway, because it'll work, just so you can check your work. Step 2, slope equals y minus blank over x minus blank. You can work with this one. It'll just make the numbers a little harder. And then you put in the back an x value in the back of x, 20,000, and a y value in the back of y, 39. So we get minus 5 over 1,000 equals y minus 39 over x minus 20,000. And then we go diagonal, diagonal. That good? Diagonal, diagonal, like always. And we get minus 5 times x minus 20,000 equals 1,000 times y minus 39. Distribute. Minus 5x plus 100,000. Distribute. 1,000y minus 39,000. We good to there? Now we're trying to get y alone. So what do we do to get y alone? Y said, I won't be alone.
Take the plus 39,000.
That's right. Add the 39,000. We get 1,000y equals minus 5x plus 139,000. Last step to get y alone. Divide by 1,000, right?
Yep.
Okay, so
Yeah, they worried for
hmm, So what's that going to be? Now that first fraction we're going to have to reduce. Let me just bring it up here. So we got minus 5
1,000 goes in the first one.
over 1,000x plus 139,000 over 1,000 equals y, right? So yeah, you can just divide it on your calculator. 5 goes into 1,200 times, right? So that's minus 1 over 200x, or you can just put the x on the top. Remember, top or front, it's all the same thing. Because to be in the front is to be over 1, is to be in the top. It's all the same. Here, just cancel 3 zeros with 3 zeros. 139 over 1, that's just 139. There we go. Oh, now, they want us to put it back in their letters. And I'll do that with you in just a second. But is everybody good to there first? Plot it back. Now, they don't want y and x. They want p, m in b. So it's just like normally we have y equals mx plus b. They have p equals mn plus b. So the n replaces the x. So it should be minus 1 over 200n plus 139. You just stick an n instead of x. Do you see how they're doing the same exact thing? They're just putting, instead of mx plus b, it's mn plus b. So n just takes the spot of x.
So when I see this on the test, and say, put in the population.
All right. So, okay, so this one actually we can do real easily. So they're giving you a real life situation. They want you to connect words with graphs with equations. It's a good problem. It's trying to help you to connect real life, words, graphs, and equations on the bottom. And the way they've set it up, one set of words matches with what's kind of a strange question. One set of words matches with one graph and matches with one equation. Okay, let's read it. You start with 3 Xbox 360 games, and each month you buy 3 new games. You start with 3 and buy 3 each month. Does one of these two, let's just jump down to the equations first. I think that'd be easier. Does one of those two equations seem to match that? You start with 3 and you buy 3. Yeah, it's that bottom one. Which number is the starting number? I know they're both 3. Do you know this number is the starting number? Remember, the number off to the right is where you start a graph. And then the other number is your slope. Right? Okay, but doesn't the second one work also? You start with 2. There's the starting with 2. And each month you buy 1. Yeah, this is your 1. So that works with the second one. Okay, but only one of the two will have a graph that fits. Which one of those graphs starts at 3 or 2? This one starts at 2. This one starts at 3, right? That's the starting point. That's the starting point. They're both looking good so far. Okay, and now, which one has the right slope?
Up 1.
So the one that starts at 3... right here, it's supposed to go up 1, 2, 3 over 1. It does. That was perfect. Up 3 over 1. The one that started at 2 is supposed to go
Up 1 over 1.
Up 1 over 1. Up 1, oh. It's not working. Right? It should be up 1, oh, it should be right there. It should be going through that dot. It's not. So our answer then is this set of words matches with this graph, matches with this equation. The other ones don't quite. They almost do, but the graph fails. This graph didn't quite. That graph doesn't fit either anything up there. Does that make sense?
Yeah, 11 follow your eyes.
Yeah, so it's all about, do you understand about the words leading to a starting point and a slope? And on a graph, a starting point and then a slope, up 3, meaning every month, 3 more games, 1 month later. 3 more games, 1 month later. Right? Just keeps going at that rate. All right. Tables. This So they're trying to help us to think about linear functions from every perspective, from words, from formulas, from graphs, and from tables. They want us to really understand linear functions. I think it's good exercises here. All right, which of these could be a table representing a linear function? How can we even know that kind of question? Yeah, because a something that's linear, if it's linear, it has to have a fixed slope.
Oh, it has to have the 0 on the.
Meaning, it has to be going up. This is the x and this is the y, right? Function values, remember h of x or f of x, this is y, this is x, this is y, this is x, this is y, right? All the function, g of x, h of x, f of x, those are y values. Okay, well that means if something is linear, that means if you go from one point to another point, however far you go up, you rise, and then you run. It just keeps doing that. Here, I should give him more room. Let me bring that down again. If something is truly linear, what that means then is if you go from one point to another point, how far you rise and then run, it keeps doing that. Same rise, same run. Doesn't it? If it's truly linear, it's like stair steps. It just keeps going up and over, up and over, up and over the same amount if it's linear. Whereas, do you realize if it's curved, it won't do that? Let me show you. Let me do a better curve there. If something is curved, it's like if you go from here to here, it's going to go up and over, but then it went up more. It's getting steeper.
So we're supposed to be able to do this without graph paper.
Without graph paper, right. So does everybody see the big idea? So for something that's linear, the rise and run is always the same. It's like stair steps, steady slope. Whereas if something is not linear, then it might get steeper and steeper or flatter. If it's a graph like this, it gets flatter and flatter. It won't be the same slope all the way, right? So how do we know? Look at how the y values are going up. We're looking for them going up the same amount every time. From 5 to 30, how much did that go up? That went up 25, didn't it? From 30 to 105, how much is that?
Not 25.
Not 20, it's like 75, isn't it? That ain't it. No.
Yeah, I think
That's the second one. 'Cause
Yeah.
it's tiny.
So how far on a number line from -4, here's 0, to +6? How far is it from -4 to +6? It's 10, isn't it? Right? It's 4 to close this gap and 6 more, 10. So that's up 10. How far from 6 to 16? How far from 16 to 26?
And you can tell that one. because-
There's our linear.
You can tell also because it starts off with -4 and 0. Because not all of them did that.
It doesn't have to start off.
Really?
No, it just has to be going up by the same amount every time. The other ones don't do that. See, this one is going down by 20, down by 20. Hey, wait a minute, that one's doing it too. Oh, wait a minute, I should have.
Oh, all of the following.
Oh, yeah, I just saw that word too, Nick. Oh, this one's linear too.
Yeah, that's what I was like, what are you
Yeah, I better look closer. I was about to move on. I was going there to say, see, the others don't. I'll say, no, it does.
Not the last
How about this one?
No.
Up by 15. No, up by whatever that is, 30. No. So just those middle two. These two are both linear because they're both going up by the same amount every time. Yeah, I should have looked for that little word all. Is that good? That's what linear means. Going up in a steady slope, going up by the same amount every time. Whereas non-linear things, curved things, get steeper and steeper or flatter and flatter. Their slopes change over time. All right. Number 13, characteristics of linear functions. So they want us to take those functions and note the rate of change and the initial value. I think this will be real easy for you. So when they give us 10x minus 2, which one of those, the 10 or the minus 2, is the rate? Yeah. The rate is always the slope. The rate's the slope. And what's the initial value? The negative 2. That's the y-intercept. That's y equals mx plus b, isn't it? So on the next one, what's the rate on this guy? Yeah, it's the second. See, that they put the letter over here now. So the slope is always what's next to the variable, isn't it? The slope is always next to the variable. So minus 9, and what's the initial value? This guy, which is a plus 9, a regular 9. Making sense? How about this third one down here? What's the rate for? Because that's next to the variable, right? The rate is, the slope is always mx plus b. M is next to x, so the slope is next to x. Slope is next to the variable. And what number's out here? Yeah, it's the same as plus 0, huh? And then the last one on this part, the rate is 0 and minus 5. Yeah, because there's no variable there, so there's nothing next to x. But the minus 5 is the initial value. That good? All right, I'll rapidly move on. I want to try to get through these for you. Write the equation of a line parallel to that line that goes through the point negative 4, negative 3. And then they're going to come down and do this. Find the equation line parallel that passes through this point and parallel to that. Spread your slope-intercept form. Write your equation in slope-intercept form using reduced fractions. Find the equation that goes through this point, parallel to that line. Use exact values. Okay, how are we doing on time? And then sketch the graph. Okay, good. So these are the big ones we have left to do. Let me make it harder, because what I'd rather do is give you one that's harder, and then the other ones will be easy. So let's do 14, but make it a little harder. I'm going to change it a little bit. Make it more challenging. Okay, let's do this. Because 16 will be that hard. So let me just get you ready for 16 right now. So let's say it goes, find the equation. Find the equation. So I'm going to make 14 harder so it's more like 16, because I'm not sure we're going to have time for all of them. Find the equation of the line. It's going through the point, I'll just use the same point they did, minus 4, minus 3, parallel to, and let me go this way, 3x plus 2y is 7 or whatever. Yeah. Yeah, good, I like that one. Let's do that. Okay. So here we are again, finding the equation. Really, it's going to be the same two steps with a small wrinkle on step 1. Step 2 will be identical. That we did before. What are the two steps we always use when we want to find the equation?
Go with the slope.
Go with the slope. So step 1.
Would the slope be, since they're giving us negative 4, negative 3, would that be the x1 and y1?
It is. This is the x1 and the y1 for sure. Good observation. But we don't have an x2, y2, do we?
Right there.
No, we can't use those that way because they're not in parentheses with a comma. They're in a formula. That's different. Make sense? So you see the difference here. They're not giving us the x2, y2. So they are giving us the x1, y1. That part's good. But they're not giving us the x2, y2, so we can't do the same thing we normally do where we do the four numbers, where we do y2 minus y1 over x2 minus y. That's not going to work because we don't have the other two numbers. We can't just grab these numbers. Those are not two numbers with a comma in parentheses, are they?
Oh, so
they're different.
So what we have to do is solve for y?
Why would we do that? You're exactly right. Why? Do you know why?
Because that's all we've been doing all this time.
That's true. Let me give you a good reason.
Oh,
Other than that's all we've been doing. Remember, y equals mx plus b, right?
yeah.
So if you get y alone,
Then you can do MX plus.
then the slope will be next to x. Remember the slope's what's next to the variable? See, we've got to find the slope for this equation. By the way, this other equation is not our equation. It's not ours. But ours is parallel to it. Ours has the same slope as it, right? Isn't that what parallel means? Two parallel lines have the same steepness, same slope, don't they? So if I can just take this other equation, get y alone, put it in the form y equals mx plus b, then I'll be able to grab his slope. It will appear at that point next to x. Then I grab his slope and I make it my slope. And then I do the same step 2 that we did before. We do the cross multiply, get y alone, using this point up here, x1, y1. That's the game plan. So let's do it. So step 1, how do we find? So step 1 is always finding the slope one way or another. In this case, get y alone so that you get y equals mx plus b. So I'll take their equation. 3x plus 2y is 7. And then I've got to get that y alone. Can you do that real quick? Why saying I want to be alone?
Yeah,
So get y alone. So what do we do first to get y alone?
take the 3x over to the side.
Yeah. And if you want, you can just jump it. How about I just do the jump shortcut?
Yeah.
What happens when the 3x jumps?
Negative.
Negative 3x, huh? Becomes, right? When things switch sides, they switch sides. Negative 3x. And now how do I finish getting y alone? Divide by 2. Just go all the way through there. Boom. Now, why did I do all this? Because I wanted the slope. Y equals mx plus b. Where's the slope? The m is the slope, is what's next to x.
3x.
Negative 3 halves. Not the x.
I'm sorry, negative
It's
3x.
just the thing next to x. Negative 3 halves. That's the slope. That's the slope of this other equation. That's the slope of this other equation, and ours is parallel to it. Ours is the same. So our line's slope is also negative 3 halves, isn't it? Because our slope is parallel to that one's slope. So now can you do step 2 exactly the same? Meaning, write slope equals y minus blank over x minus blank. Grab your slope, plug it in, and then now go up and grab your x1, y1 that have been patiently waiting for us. Grab the x1, y1 and put them in the back of the blanks behind the y and the x. Cross multiply, solve for y. Minus 3 halves. Y minus over x minus. And then grab the x1 right here and put it in the back of x. And actually, let me just put it up here so we don't run out of room so badly. Right there. Negative 4 and the y. Put it behind the y. This will be y plus 3, huh? And x plus 4. And then you know what to do. Cross multiply. Diagonal, diagonal. So minus 3 x plus 4 is 2 y plus 3. We good to there?
Yeah.
And then we distribute. Boom, boom. 2y plus 6, distribute. Minus 3x minus 12. Bring it up here. Minus 3x minus 12. 2y plus 6. Now what do we need to do? Oh, hold on. I'm sorry. One other thing. Yeah, they're going to ask for the answer in a different look. I should have mentioned that. I'm glad I remembered all of a sudden. Let's go back. Hold on. Right back here. In fact, they don't even want you to distribute. Sorry. Back to here again. Hold on. It's actually quicker. We'll be there quicker. But it's kind of a bummer. It's different because it's hard to get used to something different. So let's go back to where we were.
That'd be negative 3x plus 4.
2y plus By the way, have you, let me say a word about the negatives. Have you noticed, I always put, when I have negatives on a fraction, I always put it in the top. It's just, I think it's a good habit. So I always put the negative in the top of the fraction. So when things go diagonal, the negative goes with the top. Right? Okay, anyway. Now, on this one, they're saying to us, answer in, how do they put it? Slope. Write your equation in slope-intercept form. Answer in slope-intercept form. Never mind. Just do the normal thing.
The slope-intercept form is that you have to solve for y.
I guess so. I'll be honest. You can see, I don't know the names very well, honestly. I really don't. I just do the math. The names kind of bore me. I don't care what they're called. But I probably should care a little bit more since I'm teaching. Minus 3x minus, so yeah, no, false alarm. Now in a minute, I think they're going to have to. Anyway, let's just keep going. Yeah. Okay, now y is saying I want to be alone. So what do we do to get y alone? Minus the 6. False alarm. It's just normal. Let's get 1. Get y alone. Minus 18. Last step. Divide by 2. Now when you divide by 2, divide all 3 of them by 2. Does everybody see that? What I'm doing there? These will cancel. This is minus 3 halves x minus 9, isn't it? There it is. We got it alone. So step 1, the slope. Get y alone. So get y alone. Y equals mx plus b. So I take this formula. Minus 5x plus 6y is 4. Grab this and jump it over. And so 6y is 5x plus 4. Last step, divide by 6. Now, I don't care about reducing that 4, 6 or messing around at all, because all I did this for was to get the m. Yeah, there's the m, there's the slope, right? Is that making sense? So we take that other equation and we just get y alone. Why? Because as soon as you get y alone, y equals mx plus b, the slope will be next to x. So the slope is 5, 6. Now I just grab that 5, 6 and I go right into step 2. What do I do with that 4, 6? I don't care about that at all. Doesn't matter to me at all. I go on to step 2 and write slope equals y minus blank over x minus blank. And grab the 5, 6 and plug it in back there. Is that making sense? So step 1 is all about getting the slope. And we get the slope by getting y alone in that other equation. And the slope is next to x when you get y alone. So put the slope over here, and then you know what to do, right? Grab the x1 and the y1, and put the x1 behind x, and the y1 behind y. So we get 5, 6 is y minus 4 over x plus 4. And then we go diagonal, diagonal, don't we? And we get 5 x plus 4, 6, y minus 4. And then distribute. 5x plus 20. Distribute 6y minus 24. Y is saying I want to be alone. I'll bring it up here. So 5x plus 20 is 6y minus 4. Yeah, y is saying I want to be alone. So we add 24 like that. And 6y is 5x plus 44. Last step to get y alone. Divide by 6. But we do have to reduce that fraction, don't we?
Well, see, that was the debate that I was having. It's not a Costco package.
No. It's well, I did the 6 separately. Yeah, let me answer this question.
Okay, yeah.
See how I
If you
made it
break
separate?
all three like we did last
Yeah,
time, yeah.
that's why, to get around the Costco problem. That's exactly right, Dennis. Yeah, that's why I'm separating. You're getting it. Yeah. Okay, so then that is
It'll be
5x over 6 plus, what is that, 22 thirds? And there it is.
Yeah.
Y's alone.
I know, me too, right?